The diagram below shows a rectangular tank with base 50 centimeters by 40 centimeters, and it says that is used to store water, and the tank is filled with water at a depth of 15. Find the volume of the water in the tank. So know that volume is equal to length times width times height. That's what you'd have learned, length times width times height or depth. So in this case, the volume is just going to be 40 times 50 times 15. I'll punch all of that into our calculator. I'm just going to punch it into the calculator. 40 times 50 times 15. Punch it into the calculator, that's 30,000. So end up get that this is 30,000 cm cube. All right, that's the volume, 30,000 cm cube. Now that we get that this is the volume, which is 30,000 cm cube, that's the volume, 30,000 cm cube. We're good. Nice. Continuing now, it says the cylinder container is shown in the diagram below is used to fetch more water to fill the rectangular tank. So that means you catch water in this cylinder and then go throw it off into the tank. And then they said that a container which is completely filled with water has a radius of 20 and a height of 21. All the water in this container is added to the water in the rectangular tank. Calculate the total volume of water now in the rectangular tank. So first, we need to work out the volume of water in this cylinder. So the volume of water in this cylinder is now equal to volume of water in cylinder is pi r square h. That's how we find volume, pi r square h. So the volume is going to be, take out a calculator, it's pi times r. Wait, let me write down what r is. The radius is 20. So it's pi times 20 square times h, and h is 21. And so put all of this into our calculator. And so what we end up get is, plugging it into our calculator, it is pi times 20 square pi times 20 square, oh boy, I'm not getting the bracket, 20 square multiplied by, that's 21. We put that in the calculator and we end up get 8,400 pi. I don't want that, I want it like this. That's 26389. 26389.4. That's the amount of water that the cylinder can hold. Centimeter cube, that's the volume. Did I put centimeter cube around here? Yeah, good. All right, so that's the volume that the cylinder can hold. So now the volume of water that is now in the rectangular tank, so the new volume or the volume in the tank now, the rectangular tank, I'm going to write RT, volume for rectangular tank is equal to how much water already there? 30,000 plus this. So it's equal to the whole volume plus the volume of water in this cylinder. So add them together now, the 30,000 plus that. Don't need calculator for add them there. 30,000 plus 26,389.4. That's an easy thing for add. That's 56,389.4 centimeter cube. All right, well, nice. We never need calculator for add that. Nice. All right, now continuing, it says, show that the new depth of the water in the rectangular tank is 28.2. So of course, when you throw some water in the tank, the height of the tank have to go up. Yeah. So that means that they must say the tank now, after we pour off the water, You not gonna hear so no more. When we show off water and night, it read somewhere up here so. About 28 now. Yeah, 28. Probably somewhere there so. So come see now. Go see if it's 28. So now we know that the new volume, the volume of water in the tank, we know so it is equal to new volume is 56 something something 56389.4 0.4, and this volume is now equal to length times width times height. We don't know what's the new height, but we know the length is still 40. When we go around and show you, we know the length is still 40, we know the width is still 50, but now we don't know the new height. This is the new height, you know, just don't know the new height. There's somewhere else we just don't know the new height. All right, so it's a new height we need to find. This new height right here, so, right? So this new height is, we can call it h. Just call it h for now. So it's 40 times 50 times h. So all we need to do now is divide both sides by 40 times 50. We'll divide both sides by 40 times 50, that will leave us back just with h. So divide both sides by 40 times 50, that's gonna end up till we say h is equal to, let's work that out, 56389.4 divided by 40 times 50, and we end up get 28.19. I'm gonna round it off. So this is 28.19. And so h is indeed 28.2. All right, that never bad. So show it, h is 28.2. All right, of course, don't write a centimeter. Don't do like me, write centimeter. All right, please. But me can't bother. Write centimeter here, so you're done. But I just couldn't bother. All right. Then now it says the vertical height of the rectangular tank is 48. So that means that the maximum amount of, well, let me see. This tank right here, this would be 28 then. 28 wouldn't be so close to 48. All I'm gonna tell we say is the whole height of this thing, the whole height of 48. So probably 28 are a little bit closer to 15. That's how many want to point out. And then now it says determine how many cylindrical containers of water must be poured into the rectangular tank for the tank to be completely filled. So now, what's the maximum of water that can hold in the rectangular tank? So I'm going to write out V max. V max is how much? V max is how much water can hold in the full size of the tank. So V max are going to be length 40 times the width 50 times the height 48. That's a V max. 40 times 50 times 48. All right. So we're going to put that in our calculator and see what the V max. 40 times 50 times 48. That'll give you V max. So V max is 96,000. All right. So V max is 96,000. What that means is the maximum of water that can hold in the maximum amount of water is that right there, 96,000 centimeter cube. That's the maximum amount of water that the cylinder can hold. Now, how much there in the cylinder currently? 56,389.4. So how much water do it need to be filled? So volume, I'm going to call it volume remain, meaning VR, volume that remains that we need to get. Why is it doing this? All right, let's go again. The volume that remains in order to fill up the container is 96,000 minus 56,389.4. So 96,000 minus 56389.4. We'll plug that in the calculator again. Minus 56389.4. We'll plug that in and we'll get 39,610. 39,610.6 centimeter cube. Now that's the volume that remains in order for the tank to be filled. This is the amount of water that remains in the tank for it to be filled. So the tank needs this more to be filled. Now, how much water did hold in our cylinder again? Go around here, so let's look at how much water did hold in our cylinder. If you go on this right now, why is it not allowing me to write? Let me try that again. The cylinder can hold 26,389.4, right? That's how much the cylinder can hold. So if that's the amount that the cylinder can hold, right, and this amount of water need, right, so how much more cylinder is needed? We just need to divide. Why are we going to divide? You're going to see 3616.6. When we divide this by 26,389.4, if you put that in a calculator, what we're going to get is divide it by 26389.4. That is 1.5. This is giving us 1.5. So therefore, 1.5 more times, the cylinder needs to be filled 1.5 more times in order to fill the rectangular tank. So we can tell them the cylinder needs to be filled 1.5 more times for the rectangular tank to be filled. That's it. Very easy. There's not much to it. That's it. All right. Nice.